In this video, I will talk about the basic rational functions y equals 1 divided by x and y equals 1 divided by x squared. First, let's look at f of x equals 1 divided by x. We know the domain of this function is all real numbers except x equals 0. That is, it's negative infinity to 0 union 0 to infinity. So we can make a table of values to determine what the graph of this function looks like. We can choose values of x as long as the value is not 0. I have 0 in my table, but we'll talk about that in just a minute. So I've selected some negative values, some positive values, and then also values that get close to 0 from the left and from the right. When we replace x with these values, let's start with negative 100, we would get 1 divided by negative 100, which is negative 0.01. 1 divided by negative 10 is negative 0.1. 1 divided by negative 5 is negative 0.2. 1 divided by negative 2 is negative 0.5. 1 divided by negative 1 is negative 1. 1 divided by 0 is undefined. 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 5 is 0.2. 1/10 is 0.1, and 1/100th is 0.01. Then 1 divided by negative 0.9 is negative 1.1, repeating. 1 divided by negative 0.5 is negative 2. 1 divided by negative 0.25 is negative 4. 1 divided by negative 0.1 is negative 10. 1 divided by negative 0.01 is negative 100. And 1 divided by negative 0.001 is negative 1000. And in a similar fashion, if we substitute in the positive values, 1 divided by 0.001 is 1000. 1 divided by 0.01 is 100. 1 divided by 0.10 is 10. 1 divided by 0.25 is 4. 1 divided by 0.5 is 2. And 1 divided by 0.9 is 1.1. Repeating. And so if we actually plot these values on a coordinate system, we will get the graph as shown here. So understand, obviously I can't graph some of those points, right? 0.001 and the output was 1000, right? My graph is not going to show that very clearly, but the points I can have, I have put on here. Notice that this graph is in two pieces, which we would expect because it has a restriction at x equals 0. So the graph is going to do something to the left of 0 and to the right of 0. This is not a continuous function at all because we have to pick up our pencil to draw the two pieces of that. But notice the end behavior. As x goes to infinity, so remember as we're looking to the right of the graph, what are the y values doing? Well, in this case, the y values are getting closer and closer to this x-axis. So we say that y is approaching 0. And we can also see that from this chart, right? As x is getting really, really large, the values of y are getting smaller and smaller and smaller, and they're approaching the value of 0. As x goes to negative infinity, so that is as we go to the left of our graph, what's happening to y? Well, y is getting closer and closer to this x-axis, which means that y is getting closer and closer to 0. Now this is where the interesting behavior takes place around this restriction of 0. As we get closer to 0 from the right, y is approaching, so as we're going Now closer to 0 from the right, notice that y is going up without bound, so we said that y is going to infinity. As x goes to 0 from the left, notice that y continues to go down without bound, so we say that y is approaching negative infinity. The function is undefined at x equals 0, and as a result, the graph does not cross the y-axis. Recall the y-axis is defined by the equation x equals 0 and is called a vertical asymptote. ASYMPTOTE. It's called a vertical asymptote of the graph. Also observe that because the function value or output is never 0, right? 1 divided by a number can never be 0. The graph never crosses the x-axis. So just as I stated that 1 divided by a non-zero number does not yield 0. The x-axis, which is defined by the equation y equals 0, is called a horizontal asymptote of the graph. The domain and range of the function is negative infinity to 0, union 0 to infinity, right? Because the x value can't be 0, and then we just talked about that the y value is never 0. This function is an odd function. Do you remember us defining that? Since f of negative x is the opposite of f of x, remember that we talked about opposite x values have opposite y values, and the graph is symmetric about the origin. So if we flip the graph over the x-axis and y-axis, we'll get mirror images of each other. Now we'll look at the graph of f of x equals 1 divided by x squared. The domain of this function is also all reals, excluding x equals 0. So that is, it's negative infinity to 0, union 0 to infinity. We can also look at a table of values to figure out what the function will look like when we try to graph it. If we divide 1 by negative 100 squared, we get 0.0001. Now notice that will be positive because when we square a negative value, we get a positive number. 1 divided by negative 10 squared is 1 divided by 100, or 0.01. 1 divided by negative 5 squared would be 1 divided by 25, or 0.04. 1 divided by negative 2 squared is 1/4, or 0.25. 1 divided by negative 1 squared is 1 divided by 1, or 1. And we know at 0 we can't divide by 0, so it's undefined. And then 1 divided by 1 squared is 1. 1 divided by 2 squared is 0.25. 1 divided by 5 squared is 0.04. 1 divided by 10 squared is 0.01. And 1 divided by 100 squared is 0.0001. Then 1 divided by negative 0.9 squared is 1.234. That's an interesting number. You actually get 1.2345677 and then 9. So kind of neat to see all the numbers play out there. 1 divided by 0.5 squared, negative 0.5 squared, which will be positive, is 4. 1 divided by negative 0.25 squared is 16. 1 divided by negative 0.1 squared is 100. 1 divided by negative 0.01 squared is 10,000. And 1 divided by 0.001 squared is 1 million. Now notice we're going to get the same value when we plug in the positive number. So y divided by 0.001 squared is going to be 1 million. 1 divided by 0.01 squared is 10,000. 1 divided by 0.1 squared is 100. 1 divided by 0.25 squared is 16. 1 divided by 0.5 squared is 4. And 1 divided by 0.9 squared is 1.234. So when we graph this, we're going to get a very similar picture, except that both pieces will be above the x-axis, right? Because all the y values were positive when we squared. As x goes to infinity, so as x is going to the right, notice again that the y values are getting closer and closer to the x-axis, which has a y value of 0. As x goes to negative infinity, y is getting closer and closer to the x-axis, which is closer and closer to 0. As x goes to 0 from the right, notice the y values are going up without bound, so y goes to infinity. And likewise, as x goes to 0 from the left, the y values go up without bound to go to infinity. The function is undefined at x equals 0 and therefore has a vertical asymptote. So that vertical asymptote is a vertical line that the graph cannot cross. But the interesting thing is, as we get closer and closer to it, the y values would go off to either positive or negative infinity. So note how the graph hugs the y-axis. It gets closer and closer to it, but never crosses it. Also observe that this graph never crosses the x-axis because the function value is never 0. So y equals 0 is a horizontal asymptote of the graph. The domain of this function is all reals except for 0, so that's negative infinity to 0, union 0 to infinity. The range, though, is from bottom up, and the bottommost value is not 0, but we get so close to it that we can't distinguish it really for purposes of writing the range, so we say 0 with the parentheses to infinity. But this function is an even function, since f of negative x is actually equal to f of x, right? Opposite x values have the same or equal y values, and it is symmetric about the y-axis. So you should have in your mind the basic shape of a rational function of 1 over x and 1 over x squared, because in this section we're going to then graph transformations of those two functions.